Some events don't just change the day, they change everything. We're talking about those massive, out-of-the-blue shocks that completely rewrite history and how we see the future. These are called black swans, and today we're going to decode the science behind these incredible surprises. So where does this wild name come from? Well, it's from the work of Nassim Taleb. See, for centuries, people in Europe just knew that all swans were white. It was an obvious fact, because they'd only ever seen white swans. Then, one day, they found a black swan in Australia, and poof, that centuries-old belief was shattered in an instant. A black swan event is exactly like that. It's a total outlier, its impact is enormous, and here's the crazy part. After it happens, we all look back and convince ourselves we should have seen it coming all along. That's a little psychological quirk called hindsight bias.
You don't have to look far back, right? A totally new virus shows up, and within months, the entire planet basically grinds to a halt. Or think about a clear Tuesday morning that's completely shattered, and suddenly air travel, national security, even geopolitics, they're all changed forever. And then there's Fukushima. A massive earthquake sets off a tsunami, which then causes a nuclear meltdown. It was this cascade of disasters that almost no one had imagined could all happen at once. Every single one of these felt like a bolt from the blue, a total shock to the system. But it really makes you wonder, doesn't it? Are these things truly random acts of fate, or are we just not very good at seeing the storm clouds gathering? Is there a better, more systematic way to think about, well, the unthinkable? Turns out there is. It's a whole field dedicated to this exact problem, and it's called risk science. And it gives us a toolkit for trying to decode these potential disasters before they strike. To put it simply, risk science is the formal study of how we can prepare for a future we can't predict. Look, it's not about having a crystal ball. It's about building a framework so we can ask the right questions and get really honest about what we know and, maybe even more importantly, what we don't know. At the very heart of this whole field are 4 questions that sound simple but are incredibly powerful. First, what can go wrong? Second, okay, and if it does, what are the consequences? Third, what's the probability? How likely is it? And fourth, and this is the one that really gets people, how strong is the knowledge we're basing all these answers on? Are we sure we know what we think we know? To really see how this works, let's take a trip back in time and apply this framework to one of history's most famous disasters. It's a story where failing to answer those 4 questions, especially that last one, led to a catastrophe that was totally avoidable.
Back in 1912, the Titanic wasn't just a ship. It was a statement, a symbol of just how much we'd mastered technology. Everyone talked about its state-of-the-art watertight compartments, and that confidence bred a really dangerous belief. It was unsinkable. That one core assumption, that it just couldn't sink, became the most critical and deadliest part of its risk profile. And this is where that bad thinking becomes so clear. The designers didn't think of the lifeboats as a plan B for saving everyone if the ship sank. No way. They saw them as little water taxis, just to ferry people to another rescue ship that would obviously be nearby. Why? Because the Titanic itself was the ultimate lifeboat. Of course, the tragic reality was totally different. The ship went down fast, all alone, in the freezing North Atlantic. Suddenly, that core assumption crumbled, and the lifeboats went from being a minor convenience to the only hope of survival. And the price for that single, flawed assumption? It was absolutely devastating. More than 1,500 people lost their lives because the risk of the unsinkable ship actually sinking was considered so low that preparing for it properly just didn't seem necessary. Now, it's easy to look back at the Titanic and think, well, that was then. But the crazy thing is, the kind of thinking that sank that ship, it's all around us every single day. This isn't just about giant ships or power plants. It's about how all of us think about and manage risk in our own lives. And this brings us to a really powerful idea from the authors we're looking at today. At heart, a lot of us are already risk scientists. You don't need a fancy degree to do this because, believe it or not, you're already doing it. Think about it. Every time you look up crash test ratings before you buy a car, you're asking what can go wrong and what are the consequences. When you check out the crime rates in a neighborhood before buying a house, or you read that long list of side effects on a medicine bottle, you're weighing likelihoods and the strength of your knowledge. Even the huge public debates we have about something like climate change projections, that's all of us as a society trying to do a massive risk assessment together. So, yeah, looking at the past helps us decode failures like the Titanic.
But the real goal here, the whole point of risk science, is to look forward. It's about giving us a framework to think about the surprises we haven't even imagined yet. Which leaves us with one last big question, a question for you. What unsinkable belief are you holding on to today? And what would happen if you were wrong?